All right, we'll do a brief discussion of understanding optical illusions. And ironically, there are a lot of things you can talk about when it comes to optical illusions, but we'll keep it very simple. You have light coming off an object, and you see your brain perceives it a certain way. But the truth is, it's something else. And that's what an optical illusion is. Your brain sees, you see something, your brain interprets the image and creates a different thing for you. There are optical illusions in nature. This is when you look down the road and you see water on the road. That's caused by the heat, and it's actually a kind of a reflection off the surface, but it's an illusion because the water is actually not there. You have brightness illusions. There are different kinds of illusions: brightness and contrast, twisted chord, color illusions, perspective illusions, relative motion illusions, illusions of expression, and we really want to just give you a brief summary. This can be a very complicated topic, but I just want you to understand when we talked about the physiological, the physical, and what you perceive. So what basically happens is our vision system tries to compensate for differences in illumination. And you start to see like these things happening. And when you can study how the brain is fooled, it teaches you how it works. So illusions of the senses tell us the truth about perception. They like to see how your brain works by people describing what they see. It's also fun. And you want to ask yourself, why is our nervous system organized such that it can be so easily fooled by the gray squares on light and dark? So it's not easy to fool the nervous system, but there are some situations where it works out really well. Basically, you have negative photoreceptors in your eye and positive photoreceptors. This is in your retina, and it affects the way the light comes into your eye and how you see things. There's a gradient formed within your eye where you have more light on one side and less light on the other side. And this brightness creates like a reflection or an incident illumination. And then your brain then compensates for the effect. And then you start to see something that's actually not there. So you see on one side it seems like it's brighter, and the other side is lighter. Your brain thinks the left part of the image is getting less light as compared to the right part. Then your brain tries to compensate for the effect of lighting. So even though the intensity of the bar is the same, the brain thinks that the left part is higher. When you look at the Hermann grid illusion, you see a whole bunch of dots, but they're not really there. And it's that whole thing we talked about, the low-level explanation of the light being perceived by your eye and how some parts of your eye sees light positive, some parts of your eye sees parts negative. If you only look at one intersection, then you won't see the dots. It's when you let your look at one intersection and you see your perception around it goes, you'll see the dots. And it's because your receptive fields are smaller near the center of your eye. So when you look at the center of your eye, you don't see the dots. But around the edges, you start to see all the dots. And that's what we mean by the illusion.